Hello and welcome to the next chapter we'll be considering in this course. And it is chapter 7, where we develop techniques that we use in basic integration. Earlier, I think you should have encountered two of the most important techniques of integration, which is integration by substitution. Later on, we'll be considering another integration by parts. For integration by substitution, I believe you may have come across that in your Calc 1 class. I'll briefly review that in two videos here just to refresh your memory. However, this portion of the lecture should start from integration by parts. Now, we introduce these techniques and see different functions, how to integrate them. The aim is that by the end of this chapter, you should have developed enough flair in integrating functions depending on the way it is given to you. It is good to note, however, that it's not every function that you can find the indefinite integral, but for the most of them, you should be able to know how to integrate after this video or after this chapter. Integration, as you may have known, is not the same as differentiation, where you just have straightforward rules, maybe sum rules, difference, quotient rule, product rule, function of a function, and things like that. When integrating functions, the two major techniques that we'll be using is substitution rule and integration by parts. But apart from that, others may come from either what you already know from differentiation or maybe some ingenuity. So from section 1 to 7.1 to 7.4, we'll be looking at some techniques, and in section 7.5, we'll look at how we can combine or how we can use those different techniques if we are given a problem. It's good you pay attention to the information presented from chapter 1 to 7.1 to 7.4 to be able to have a strong grasp of what this chapter will be all about. Now we know that integration is the reverse or opposite of differentiation. So if we have a differentiation rule, there would be an integration rule that corresponds to it. For example, the substitution rule of integration, usually called U sub, corresponds to a differentiation rule called chain rule. Also, the rule that corresponds to product rule for differentiation is integration by parts that will be seen very soon. To begin our review of integration by substitution, we'll start with just trying to tell you some of the things you may have already known. If you want to study this more deeply, that is integration by substitution, you may have to check out section 4.5 in chapter 4 of the text that we are using. Now, substitution rule works whenever we have an integral that can be written in the form f of g of x multiplied by g prime of x dx. Here we can observe that if we left our f to be big F prime, then this integral here can be written as big F prime of g of x multiplied by g prime of x dx. And this is just kind of like if we are differentiating the function big X prime, because by chain rule, if we have a function big F of another function g of x, if you differentiate that, you're going to differentiate the outer function first and then the inner function using function of function rule. And integrating both sides gives you, like, if you integrate this again, you get what you differentiated, which is this, plus a constant c of integration. And now we could say let our u to be equal to g of x. If I let my u to be equal to g of x, then my du becomes g prime of x dx. So in that case, this here becomes my u, or probably here. This here becomes my u, where my, yeah. And then this is gonna be like g prime of x dx. All of this becomes d of u. So if we replace this by u equal to g of x, this is what we'll be getting in terms of u. Generally, substitution rules say if you have a function of another function, and then in that function, the derivative of the function inside occurs outside the other function, then you can actually carry out substitution by letting your u to be equal to g of x, and g of x should be differentiable. If that's the case, you make the substitution and then get just only one function and integrate that. This looks more hand wavy. However, I basically don't want to go into too much details. Now let's look at some example on how this could be used. Now if you look here, we are asked to find the integration or the integral of x cubed cosine of x to the power of 4 plus 2 dx. And now if we differentiate this function x to the power of 4 plus 2, we get 4x cubed. That tells me that the derivative of this actually occurs partially outside. The constant doesn't really matter. So how do we differentiate? Well, since we've seen that the function appears in the way we can make a u substitution, we integrate by letting our u to be equal to the function inside. And what is that function? X to the power of 4 plus 2. This implies that the u is equal to 4x cubed dx. However, in my original function, I only have x cubed dx. So if I divide both of these by 4, I get that my 1 over 4 du is equal to x cubed dx. So with this, I can now make the substitution. My integral is x cubed cosine of x to the power of 4 plus 2 dx. My x cubed dx is du, or is 1 over 4 du. So I'm going to have integral of cosine of u multiplied by 1 over 4 du. Cosine of u, we replace this by u, and this here and this is 1 over 4 du. That tells me that this is going to be like 1 over 4 integral of cosine of u du, which is basically equal to 1 over 4 sine u plus c. Now, if you make a u sub, when you are done with the integration, your answer should go back to the original variable you're working with. We are working with x and not u, so I have to replace my u with its value. This is 1 over 4 sine of x4 plus 2 and then plus c. This is the integral of the function that we are given. Next, let's look at one other example on this integration by substitution, or u sub as you may call it for short. We are asked to find the integral of the square root of 2x plus 1 dx. Now the main function here is square root, but inside this square root function there is another function 2x plus 1. So we could let me write that here. We could let u to be equal to 2x. This means that my du is equal to 2 dx, or my 1/2 du is equal to the x. Why am I writing it that way? Well, I only have the x here, so I want to replace the x and replace this. This tells me now that by making the substitution, this integral becomes integral of square root of u, and then my dx is 1/2 du. I can write this as 1/2, bringing the constant outside, integral of square root of u du. And this is 1/2 integral of u raised to power 1/2 du. If you integrate this, you get 1/2 multiplied by u. Integrating this gives me u raised to power 3/2 divided by 3/2 plus c. If I simplify that, I get 1/2 multiplied by 2/3 multiplied by u to the power of 3/2 and then plus c. And that will give me u to the power of 3/2 all over 3 plus c. But then we have to take our solution back to x because the problem was given in x. So this is going to be, our u was 2x plus 1 to the power of 3/2 and then divided by 3 plus c. So this becomes our integral. Now usually it's also possible for you to make another substitution and it's still going to work. For instance, look at this. I try to use another pen to do this. Or for integral of square root of 2x plus 1 dx, we could let our u to be the whole of square root of 2x plus 1. Yeah. And then what is going to be our du? If we differentiate this, this tells me that my du is going to be equal to, I'll get 1/2 first when I differentiate the square root. If I differentiate 2x, I get 2. Then I'll get 2x plus 1 to the power of 1/2 minus 1 is negative 1/2 dx. This is the same thing as 2 is going to cancel out. I just have like 1 over square root of 2x plus 1 dx. That is the same thing as 1 over u du. Notice our dx, please. Notice here that our u was square root of 1 over this. So that tells me that if I multiply both sides by du, I get that u du is equal to dx. So that my integral now becomes integral of square root of 2x plus 1 is u multiplied by my dx is u du, which is the same thing as integral of u squared du. So if I integrate this, I get u to the power of 3 over 3 plus c. But what was my u to the power of 3? My u was 2x, square root of 2x plus 1. So this is going to be square root of 2x plus 1 all to the power of 3 divided by 3 plus a c. Now another way to write this is just the same thing as what we got earlier. This here and this thing are just two ways of writing the same. So you could make a substitution and someone else makes another substitution and both of them will still work to give you the right solution as far as you do the right thing. Another thing I would like to point out about integration by substitution is when you are carrying out definite integral. Sometimes many people make a mistake when it's definite integral, they don't take it back to the original variable before doing the substitution, and as a result they may make a mistake. In the next video I'll point out that error and let you know how to avoid it.